All right, everybody, good morning. Welcome to our open day, where we will talk today about the MSc in Future Manufacturing and Nanoscale Engineering. What we will do is we will give a brief introduction to the program. I will take you through what the purpose of the program is and what the modules that are taught in there. And then after that, we will do some question and answer from everybody. If you have any questions, you can simply type them on the text box in here, or you can just raise your hand and I can unmute you. So I will share my screen. I will just share with you here just an overview of the program. Here we go. So yes, the program that we'll talk about today is Future Manufacturing and Nanoscale Engineering. My name is Eral Bele. I'm the program director, and I have with me here today Dr. Zareena Gani, who is one of the lecturers in this program. Essentially, let's just talk about what this MSc is about. It's, as the title suggests, about manufacturing and nanoscale engineering. So what we will train the students to do is to design, characterize, and manufacture nanoscale or nano-engineered materials. This is a growing field, and it requires people who are trained in this kind of technology and this technical content. So the purpose is to train you to become leaders in this growing field. Nanoscale engineering and generally nano-engineered materials can mean a lot of things to a lot of people. This program is about solid-state materials. In other words, materials that you can touch and see. And we designed these to have unique properties in the mechanical properties, for example, optical properties or thermal properties. And then to give you just some example about focusing your attention on what they are, we will teach you about how to design coatings, for example, for color or wettability or antifreeze properties, anti-fogging properties, and so on. We'll train you to design composite materials with unique mechanical properties, very high strength, very high stiffness, for example. Other things would be custom design materials for 3D printing and additive manufacturing, and technologies for precision manufactured components. So all of these fall within this category of materials that are engineered in the nanoscale. I'll give you just some visual examples so you can see here. In the left-hand side, there is a surface in there, and you can see that we're putting droplets of water in there, and it's taking away this black thing. This black thing is a simulant for dirt, for example, on the surface. And if you look very closely, what these droplets are doing there is that they are just rolling off the surface instead of sitting there and making more of a dirty mess, essentially. The idea is that if you engineer the surface in such a way that you can make these micro hills, essentially, you don't make the droplets spread out like this, but you let them be intact and roll. And if you can imagine that this is a dirty surface and the droplets are rain, for example, it's simply a coating that can be applied on walls and all kinds of surfaces so that it can become a self-cleaning surface. It just cleans itself from any type of liquid. So that's one type of material. And on the right-hand side, you see a very small lattice. This is essentially an engineered material where we put the material where it mostly matters. In other words, it's a very tiny bridge, okay? It's very lightweight. The material is designed to be where it can resist the forces. So essentially, you make a very lightweight and very strong or very stiff material in this way by just engineering these features at that very small scale that you see there. So just some examples to make you situate what nano-engineered materials are. So how is the program structured? This is a small depiction of all the modules that we have here. This one here in the left is term 1. We have there some fundamental modules, fundamentals of nanoengineering and advanced characterization and laboratory techniques. And there is an elective module which can actually be taken in either one of the terms. And then in term 2, we have specialist modules. We have modules on nano-architected materials, materials designed for manufacturing, and then precision manufacturing. So those are the technical modules. You'll see in the bottom that there is a module that spans both term 1 and term 2, and this is called Group Manufacturing Challenges. I'll describe more about what this module is, but in a nutshell, it is about short, about 5 weeks challenges where you will learn by doing. We're going to have manufacturing challenges from each one of these modules, number 1, number 3, number 4, and number 5, and you put your knowledge to practice to design something, make a prototype, test it, and then communicate the results. So that's all about learning by doing, essentially. And then in term 3, we have the advanced research project. This is term 3 in summer. And here you will be working on, as the title suggests, on advanced research projects. And I will describe a bit more later on about the types of projects that you will be working on. So that is the structure of the program. Okay, all of this is done in 1 year. So let me just take you very briefly through all of the modules. The first one is Fundamentals of Nanoengineering, and this module is about how you are able to design materials in the nanoscale for desirable mechanical properties, electrical properties, and tribological properties. Tribology essentially means friction, and tribological properties that are desirable are surfaces that don't wear with friction. For example, in cases of automotive industry, aerospace industry, and so on, they want surfaces that will just stay intact from continuous contact. There is a practical element in this module, and it has to do with training you on how to make these materials, so nanoscale manufacturing technologies. The second module that is also a fundamental module is advanced characterization techniques. And this module is about teaching you how to see and test materials. So you would want, for example, to test the mechanical properties of materials, indentation, hardness, and tension. You could want to see the microstructure or the subsurface analysis. You might want to analyze your materials and your structures for chemical composition. You might want to, for example, measure the surface quality of a part that you have made. And we teach you all of these techniques here in this module. And all of these are practical. In other words, you go into the workshop, you go into the lab, and actually manipulate and use all of these machines so that you can get practical experience in them. Then we go into the modules that are more specific to the program. One is nano and micro-architected materials. These types of materials, I described them a little bit earlier, but they are of two types. They are either nature-inspired materials that are very efficient, and think here about materials that are super strong, like the shell of nacre, for example, and of many mollusks, that is very, very strong, right? And it is so strong because it has some very special architecture in the micro nanoscale. So that's one kind of material. And the other kind of material is something that is specifically engineered to have a property that is not found in natural materials. I go back to this little lattice that I show you here. If you can imagine squishing this lattice, compressing it, you will see that these curvy struts, okay, they actually bend. And what they do is that they make this material here contract when you compress it. Okay? And if you stretch it, it does the opposite. So you stretch it and it becomes larger this way. This is unusual among natural materials. Typically, when you stretch something, it thins, okay, and when you compress it, it expands. And the reason why something unnatural like this is desirable is because it's very good for absorbing energy. So this has already been applied in practice for soles of running shoes, where you, when, for example, you hit your foot on the floor, it absorbs more energy because it just takes all of that energy and it contracts. Okay, and then when you release your foot, it expands and it just gives you back that energy. So it makes it easier to run. Just some example on that. And what we will be talking about in this module is how do you design such material? How do you do structural analysis on them, and how do you manufacture them? We talk about composite materials and lattices, like we mentioned here. There is a practical part in this module as well, and it has to do with mechanical testing, manufacturing of composites, and finite element analysis, which is a computational tool for stress analysis. Then we have a module on materials designed for manufacturing. This has to do with enabling you to design new materials that don't exist yet, but that will be needed in the future. And you do some case studies here on how manufacturing in the future, we need new materials, and you design some unique and novel materials in here. There is a practical part as well in this module, and it has to do with computational modeling techniques to design and drive these new materials. And then the last one on the technical modules is precision manufacturing. This has to do with really making components in the nano and micro scale. So you will learn here about what methods do you have in the additive and subtractive manufacturing technologies, what are the machine tool requirements, consumer needs, applications, and this is very industry driven. So you'll learn about the current practices in industry. Crucially, in this module, you get some practical hands-on experience with high precision CNC machining and surface measurement. So you see that in all of these modules that we teach already, they have some practical focus on them, so that you don't just learn the theory, but you actually put it into practice. But where you really put the theory into practice is this module that I mentioned earlier on manufacturing challenges. Essentially, what we do here is that we help you to learn the technical content by actually making something by yourself. We have here 4 challenges of about 5 weeks each. All of them are industry sponsored, and they tackle something that is new, or something that is a challenge to manufacture, for example. Something that in the future, in the next 5 or 10 years, might be very big, but at the moment it has some challenges that you can really think about solving. So, for example, some just indicative challenges here is how to design and manufacture a nanoscale flexoelectric energy harvesting material. Lots of words in here. What this type of material is something that when you press it, okay, it produces and stores energy. Could be good, for example, to get some energy when you're walking on the floor or something like that. So flexoelectric means that it flexes and it produces energy, or harvests energy more specifically. Another one could be to design and manufacture a 3D printed fiber reinforced material now with ultra high strength for an automotive component, for example. Another challenge is a design of a new alloy, new material for additive manufacturing. And one more could be to design, fabricate, and analyze high precision components, and also measure how precise they are and what kind of surface tolerance they have, both in additive manufacturing or 3D printed, or subtractive manufacturing or machining, right? That's what it means, subtractive manufacturing. And finally, we culminate all of this module with a community outreach event. We have a presentation where you can interact with local industries and national industries and present your results to all of them. So these are the modules that are taught. Then during the summer, there is an advanced research project. Here, you work in small teams of typically 2 to 3 students during the summer on an advanced research topic. Generally, these research topics are things that are new, unsolved, exciting, right? And they are proposed typically by industry, but some of them are also proposed by our academics in here. And the idea is to replicate the settings that you would see if you were to work in research and development in a department like this for a big company, for example. So you'd work with your small teams, you would have your objectives in there, and in this 5-month project, essentially, you work with a team in order to do this research project. Okay, and then there is this elective modules. There is many modules that are possible to take, and the objectives of this module is to extend your knowledge on something that you want to give a flavor to your degree, something that either really interests you or something that you are curious about. Okay, it could be something that is technical, like sustainability, digital materials manufacturing, materials chemistry, nature-inspired materials engineering, or it could be something that is more socially forwarded. So, for example, it could be something like entrepreneurship. It could be about social justice, innovation for a fairer world. There are many of these modules in here. All of these ones that I've put the titles here are modules that are existing, They are developed specifically for UCL East, and it's possible for you to take them, but there is many more in addition to these ones. All right, so that is the structure of the program. I hope that I've clarified essentially what the teaching would be like. I wanted to close this with just a bit of justification and a bit of motivation about why why this program. Okay. What we want to do with this is something that we have heard from industry that is needed. Essentially, industry needs this tool set that is very valuable of students who have hands-on experience. And this experience should be industry relevant. And generally, it's about designing, making, and characterizing material in this micro and nanoscale. You would leave the program with a mastery of knowledge in these manufacturing technologies, both the additive manufacturing or 3D printing and the top-down or the machining, the precision machining. And you will get very sophisticated and broad knowledge in applying these manufacturing technologies to real-world problems, like what we mentioned in the manufacturing challenges. So that is the purpose of the program. So why have it now? Why have it as a new program, and why launch it now? You have seen that the development of these 3D printing technologies and precision machining technologies is very rapid. They are now everywhere. If you think about their state 10 years ago, or even 5 years ago, you would never had imagined that we could get 3D printers sitting in our desks, sitting everywhere. So it's a very rapidly growing field, and it's something that will have a large impact in the future. This industry needs leaders. It needs leaders with vision about what is coming in the future, and also the practical know-how. That's why we are launching it now, and that's what we want to give you essentially as a tool set. So then what is in it for you? What do you get from this? You get some demonstrated skills. In other words, in your CV, for the next stage in your life and your employment, you will have some evidenced practice in creating solutions to challenges, making prototypes, and assessing how well they work. Okay? You will get some general knowledge that will be applicable to many types of industries on how do you manufacture materials and structures. And you will also get very specialist knowledge on this high precision manufacturing and nanoscale engineering. There is a large industry growth here in aerospace and automotive, energy, sustainable manufacturing. All of these industries need people to know about these things and to have actually hands-on knowledge and practice on how the technologies of manufacturing operate. Okay, that's what you will get really in the end. But there is something more that is also as important as the technical know-how, right? You are at a stage where you will need to not just learn, but also live, right? So you need to be inspired, and you really need to like what you're doing and think about where the future is taking you. So this has to do with inspiration. You know, how inspired will you be by what you learn and what you do, really? This MSc will be in our new campus at UCL East, where essentially you will need to be immersed in the local culture of UCL East. You will live, you will learn, you will be inspired by this new campus. You will see that there are brand new buildings in there, labs with a lot of light. And generally, East London is a very creative place and a very vibrant place, full of startups, for example, and full of really people who will be just like you, who will think about the future and who will want to influence the future. Right, so that is a brief nutshell, just an explanation about what the program will be about. Thank you very much for coming. Thank you for listening to this presentation. There is my contact in there. You can contact me anytime if you have questions about this program or indeed about UCL East. I think that the slides will be shared with everybody. And since we are recording this, we will also record the presentation so you can refer to it later. Great. So thanks, everybody. I will stop this now and we can start taking questions. Any questions from anyone? Okay, I can see it in the Q&A. There is a question here on what are the skills that we will learn in this MSc aside from the specific technical content? It's a very good question. As you can see, it's an MSc with a very focused content on this nano scale manufacturing and nanomaterials and nanoengineering materials. But in order to be able to learn these types of materials and how to create them and how to design them and so on, you need the types of transferable skills that really are needed in any industries that has to do with manufacturing and materials and structures. And these skills are: how do you design something? Okay, how do you make it? Do you know what technologies to use? Do you know how they work? Do you know how you will operate this machinery? What are the requirements for it? How many parts can it produce per hour? What kind of tolerances does it have? So this is about how to make it, and then how to test it, right? So there is something that you make, something that you have designed. How do you test to make sure that it has the criteria that you want, the objectives that you want? And then finally, they want people to be able to communicate all of these results and all of these processes to the society, to other technical people, to clients, and so on. So this process, these skills of designing, making, testing, and communicating are threads in our program that will be taught in all of the modules. Okay? Not just the specific technical content, but also these skills that are really applicable to many industries, and that you will be able to put in your CVs and to talk about with a lot of excitement, we hope. Okay. Then there is some question here again in the Q&A forum: what kind of facilities we will have to work with? As I mentioned before, UCL East is a new campus, and in this campus, the buildings have just been finished, and they will have brand new laboratories that are open space. Okay, and they will have a lot of machinery laboratories and also manufacturing facilities that people will use. For our students in our community, some of these facilities will be very crucial. One, for example, is the Institute of Making. This is a very large facility where all of the UCL East community, but particularly the students, will be able to go in, choose what kind of machine they want to use, and make something. It could be a CNC machine, it could be a 3D printer, it could be a laser cutter, it could be a saw, it could be even a sewing machine. And people will be able to go there, book this machine, and then create something with that. We will have new labs, both the kind of dry labs and wet labs. In other words, labs where you do something chemistry related with, and labs where you actually use machines and testing equipment. So those will be our labs where we will do a lot of things. There will be then what we call pods, or research sort of small pods, where we will have the equipment that is very high end, that is very precise, that is very large and technical, and then you will be able to see their researchers working, and likewise contribute through your research projects on the use of this machinery. And we will have also access to a precision manufacturing workshop, where you will be able to go and make things of high precision by yourself. Okay. So these are some of the questions. There is another one here on, can you tell us more about the Manufacturing Futures Lab? So Manufacturing Futures Lab is where our program will be hosted. That's the home of our program. and essentially is a very interdisciplinary lab that is made of 4 departments. There is mechanical engineering, chemical engineering, chemistry, and biochemical engineering. Okay? Researchers and teachers and students from all of these programs will be housed in this manufacturing futures lab. There are facilities that are shared by everyone, so people will be able to see essentially how not just the mechanical engineering research and work is done, but their neighbors are going to be people from chemistry, for example, or people from chemical engineering. So you'll be able to interact with a lot of people from different disciplines and perhaps get new ideas and get new inspiration for different things, both related to the things that you learn, but also about the things that you will be working with perhaps in the future. And I think that one of the most important things that students take from MSc programs is the networking part. Okay, so you will meet new people. You will essentially get to know the future leaders in many fields. So these kind of connections that you make while you are in this interdisciplinary facility are super important. They are the ones that get you into places, and they are the ones that really open your eyes about what is coming in the future. Great. So there is another question here on what are the practical skills that we will learn and that will equip us to be career ready. Okay, let's take this question. Perhaps I will ask Dr. Gani to answer this question on what practical skills will equip students to be career ready.
Right. Thanks for the question. That's a very interesting one. Actually, from the explanation that you just received from Professor Eral Bele, you would have understood that the kind of labs and the future manufacturing lab, the innovation lab, and the other labs that he's explaining about, it's all with the intention to get you all the skills that are required for you to be career ready. For example, if you're talking about how to architect material or how to use the machines, the precision manufacturing, the 5-axis CNC machine, or the metrology equipment, or the material characterization techniques that we just discussed about, it's not just in books, it's not just theory. You will be trained by professionals, professional technicians who are well versed in using these machines, and by academics like us, to help you gain the theoretical knowledge as well as the application of this knowledge. So when you go to the industry, nobody cares about what you learned. It's all about application. So I believe this is the best platform for you to apply what you learned, and you gain the skills, the technical skills and the professional and durable skills that will help you to, excel in any career that you would go forward with.
Great, thank you. Another question that has come up is how much of the course is at UCL East and how much on the main campus? This course is wholly based at UCL East because we have all of the facilities both for teaching, making, and characterizing everything that we want. It's all in there and it's all ready for us. Lecture rooms are new, workshops are new, so we have everything that we need in there. And it's wholly based at UCL East. There will be some sort of demonstrations and some kind of activities that might actually come and take place in the main campus. And this could be, for example, to see a very special lab or a very special machine. We take you here and we show you how it has been used in here. So there is some interaction between what we do at UCL East and what we do in the main campus, primarily so that you can be able to see new things here in the campus in central London that generally don't exist in there. So these are just really big machines and so on that we don't have in there, and we bring you here. Okay. Yes, other questions? Okay. I see that these are all the questions that have been posted in the Q&A session. As I mentioned before, feel free to contact me anytime if you have any questions or if you want to discuss things further about this program. I will be happy to answer those questions. All right. Thank you very much, everybody, for coming. Really good to see you, and I hope to see you soon in the future. Goodbye.